Hello, my name is Amao Ibrahim Oladipo. I'm a student of University of Abuja, Department of Mechanical Engineering. Today, I'll be optimizing an agricultural robot using Altair inspired software. Let's dive into it. So I started by importing the CAD model of the agricultural robots into Altair inspired workspace and go on to change the color of each component in order for me to differentiate it. I simply selected an auto color in the view option. Next, I created a reference flow which acts as my base and ensures I can set proper constraints for the simulation. After creating the flow, I simply change the color to make it look a bit more colorful. I selected one of the tire joints and click I on my keyboard to isolate the components. Since all the four joints are linked together, I used a partitioner tool that is located under geometry options to section some parts on the joints. To keep my workflow efficient, I selected all the four joints and break the instance that link the components together. These steps make it easier to track each part independently during optimization and also reduces the computational strain on my system. I defined a rigid group of certain components so that they move as a single unit without deformation. Then I move on to grinding the floor created using the ground tool. This tells the inspire that the floor remains stationary, providing a fixed reference point for all moving parts. And then I select the joints tool to define how each component interacts, specifying joint types like revolute or cylindrical or hinge. I also created contacts between the tires and the floor to simulate realistic friction and movement conditions. Center of gravity was set to y direction and motor tool was selected and applied to all the hinge in the assembly. Next, I assigned titanium as the material for all joints. Then I run an analysis over 1 second. This helps me spot potential stress concentrations and area where the joints might be overbuilt or under strain. One of the hinge joints was selected and an analysis was conducted on it. I make sure to set my analysis solver to same solid in order to have a faster result. I run the analysis. The analysis was completed. The result shows that the component can be optimized by reducing its mass without losing its structural integrity. Then I proceeded to setting shape control and manufacturing constraints to ensure the optimized design is practical to produce. And then I selected the design space set to maximize stiffness and keep 40% of the design space. And run the topology optimization analysis. Through these steps, I have successfully optimized the tire joint of my agricultural robot using Altair Inspire. This process not only reduces material usage and weight, but also enhances overall performance for real-world conditions. My special appreciation goes to Altair for giving me this incredible opportunity to showcase my skills and learn cutting-edge simulation techniques. For more information about Altair simulation tools, kindly visit the link provided on the screen. Thank you.